Okay, suppose we have 7 gallons of water containing 14 ounces of salt. Then what's the concentration of salt in this solution? Now, the question comes out in the context of one of the homework problems. It's often troublesome. Mixture problems tend to be problematic for students. Okay. Matter of fact, I remember breaking a couple of boxes of pencils over a problem involving nuts and mixtures of nuts. It's hard for me to understand. And of course, I was only 6 years old. I could barely break a pencil. But no, that was when I was freshman in high school. I could solve just about everything that came at me, but those really confused me. So I'm not too surprised when my differential equation students have trouble with mixture problems in a somewhat more complicated situation. Okay, but it's something that's, I think, inherently difficult. Okay, well, anyhow, 7 gallons of water and 14 ounces of salt. So first of all, what would you say the concentration of salt is in this solution? Okay, now we had a good intuition. You got a number of ounces, number of gallons, but then got all confused. Do you put this over percents? What do you do? What do you do? What do you do? No, you don't do any of that. Okay. And we got to that very quickly. Okay. You got 14 ounces and 7 gallons. How many ounces is that per gallon? Okay. And it's 2. Okay. So it's 2 ounces per every gallon. Okay, that's pretty obvious. And when I phrased it that way, told it pretty much immediately. Okay. How do you calculate that? Put the 14 ounces over the 7 gallons. Okay. It's the amount of stuff you have in the water divided by the number of gallons of the water. Okay. Okay. Now we can connect that 2 ounces for every gallon. That's 2 ounces per gallon. And ounces per gallon is written ounces over gallons, which tells you what you do with the ounces and the gallons. Fine. Okay. Okay. Now, if I add two things I can ask here, but the most relevant thing to the problem you're talking about I have X gallons of pure water, then what is the concentration? Okay. We have 7 gallons plus X. Don't have a lot of room, then we'll get it all together. Say the salt, we still have 14 ounces, right? So concentration. And with your permission, I'll use a capital C for concentration. 14 ounces. Over 7 gallons plus X. Now notice I didn't say 7 plus X gallons because X is already in gallons. And if you say X gallons, you got X gallons. Okay, and you'll see how that works out in a minute when we pose the big question. Okay, so now now if we want concentration of 1.3 ounces per gallon. How much water must be added? Okay, now I got something different, but looking at the work, I don't see anything wrong with it. But I'm not looking real close. I don't have my glasses on. So I'm not really scanning all of the details. Now my glasses are right there 2 feet away and I could have put them on, but it's more fun just for me to do it wrong too, and then we'll figure out what's right. Okay, there's nothing at all wrong with the procedure. The equation was good. You wrote down the equation. $14 ounces over 7 gallons plus X equals 1.3 ounces per gallon. Now, I've got my ounces and gallons throughout the equation, okay? I don't want gallons on X because X is already in gallons, okay? It's more or less optional to keep those things there, but it's more secure if you do keep them and you understand better what's going on if you do. So it's kind of a choice. I think open math is like you just say, okay, the units work out, so we're just going to do it. But kind of important to do the units. So, well, what do we do here? We do what we always do if we have a denominator. Well, plus 7 gallons plus X is 14 ounces over 7 gallons plus X. And put a 1 down here just to make sure we understand that. I know we do. And then I could write this as 1.3 ounces over gallon. Then times 7 gallons plus X. Over what? Trying a lot of strange stuff here, like there's a parenthesis in there that came from somewhere. Obviously. Simply they must have imagined. Okay. Okay, so we can do this, okay? Then we know that the 7 gallons plus X and the 1 could be interchanged, or would you give us a 1 here, so we have 14 ounces. That equals 1.3 ounces per gallon times 7 gallons over 1 plus it is 13 ounces per gallon times X per gallon. Okay. So now 14 ounces equals 1.3 times 7 is 10.1 ounces over gallons times gallons over 1. The gallons, you go over here and divide the gallons. So we get 10.1 ounces here. It's 1.3 ounces. I really didn't write that. Now that can be rearranged. We subtract the 10.1 ounces from the 14 ounces, we get 3.9 ounces. So this is ounces per gallon. And I don't have an X over 1 anymore because what I'm going to do now to solve for X is I'm going to divide by 1.3 ounces per gallon. Okay, so this gives us 3.9 ounces is 1.3 ounces per gallon times X. I'm going to say we multiply by the reciprocal of this because it's easier than dividing. Okay, we multiply by the reciprocal. Now, this gallon could be written as 1 gallon, so we have 1 gallon over 1.3 ounces times 3.9 ounces over 1 equals 1 gallon. And we see that this could be rearranged as 1 gallon over gallon and 1.3 ounces over 1.3 ounces. So we're just going to end up with X. Okay. So X equals what we get when we multiply this out. Okay. And that's going to end up being 1.3 ounces into 3.9 ounces is 3. I'm going to write that step out because it was a little weird. We find that X is 3 gallons. And that's not right. you know, I did my arithmetic wrong here. I got 10.1 when I should have gotten 9.1. I know darn well that 7 times 13 is 91. That's something that's hard. So this 10.1 should have been 9.1. And this 10.1 should have been 9.1. Incidentally, the reason I realized I made a mistake is if you add 3 gallons to this, you have 10 gallons with 14 ounces of salt. That's 1.4 ounces per gallon, not 1.3. That should have been 9.1. So this 3.9 should have been 4.9. Erase it and have it down again. Okay. 4.9, 4.9. So now 1.3 doesn't go into 4.9 quite as nicely. Okay. And what we get is 3.7, 3.77 about. That's approximate. That's not in my head. You can use a calculator. That's 14 over 11. It would be a little less than 1.3. 14 over 10.77. Well, if we do 10.77 into 3.23. Seven might be a little hot, but you can check it out. This is about check my arithmetic, dividing 1.3 into 4.9. And 1.3 goes into 5.2 4 times. Now 3/15, which is about a third. Yes, we're going to be a little less than 7.7, 7.2, 7.3, somewhere around there. Okay. Now, if it's confusing to have all these ounces and gallons, although you want to see that, okay, you kind of left it out, but not completely, and solved it, okay? And do you see an error in what you did? Okay, so in that process, we found a mistake that was made out there. And just in distributing it a little carefully. Okay, you want to be real careful about that. I couldn't spot it. It looks so good. But it's kind of small. It didn't look that hard. Okay. It doesn't mean I would have found it if I'd looked. Probably would have. Okay, so we have light intensity. And the intensity of light from the source. Imagine you have a candle or an LED, but LEDs are a little bit directional, but anyhow, you have some source of light here. Well, as the light spreads out, it gets less intense because there isn't much of it to go around. And imagine that light spreads out on a sphere. Okay, if the sphere is this big, then the area of the sphere is, well, whatever the area of the sphere is, okay? Now, if the sphere is this big, well, you have a much bigger area. Okay. And it turns out that the area of a sphere is proportional to the square of its radius, circumference, diameter, whatever. Okay, proportional to any linear measurement. Which means that since you're dividing how much light there is by how much area, find out. Can you read paper at this distance? Okay. Then the intensity of that source is going to be inversely proportional to the square of the distance. Again, the area of the sphere is proportional to the square of the distance. So the intensity, when you're dividing by the square, the area, is going to be inversely proportional to the distance. Okay. So this is from the source. And I use L ambient for the ambient light. So if we have a bright light in this room, it's going to make things even brighter the closer you are to the light. Okay. Now, if the light's not real bright, if you get out to the edges of the room, it's not going to make much difference because there's a good bit of light in the room to start with. All right. But that's the ambient. So think ambient, just a light from our overhead fluorescence. Okay. And then light from some source. Here we got a bulb. Okay, spreads out. So that's a little background. You don't have to know that to solve the problem. But there are reasons behind this that I thought I'd share with you. Okay. I could go much deeper into it, but that's way into the physics. Okay. The proportionality of this area of the sphere and the inverse proportionality. You kind of understand that. Okay, so now we're given the 10 centimeters. Light is at 185 lux, 182 lux. Okay, so 10 centimeters, L equals 182 lux. Source off. And nope, sorry, with the ambient light, and say with the lights off. Let's say the room lights are off. So the room lights off means your ambient is 0. So and this, not getting all the information right. This is not at 10 centimeters. This is just what your ambient light is. Ten centimeters with the lights on. L equals, you should have remembered that number, but I didn't look at it. Might have forgotten it anyway. 2475 lux. Okay. Now we want to figure out what the ambient light is. Well, first of all, I think I've got my information on. No. I don't think it's the room lights that are off. I think it's the light is off. One of my glasses, I'll look at the screen too. So what we conclude is, sorry for the confusion, L ambient is. I should have read the whole problem before I started explaining it. Okay. So now that I've got the information there. Correct. We understand. Say that 182 lux, and it's not the room light that's off, it's the light. Well, that's the source light. Okay, so 10 centimeters, if the light's on, L is 2,475 lux. Now, at this point, remember what we do with proportionality. A is going to be a proportionality function. We have enough information now to solve for K. Okay, so now we can solve for K. So go ahead and see if you can solve for K, given the information. Okay, so finally get the information right. I do apologize for reading my screen wrong. Okay, it's not my screen's fault. There's the information. It wasn't making sense the way I had it originally. Okay, so now we can solve for K, because we can plug in 10 centimeters for X and 2475 lux for L, and we know what the ambient is also. So we can write the equation. There's our equation. It's not L ambient anymore. We got a number for that. We're going to 2 lux. So we can subtract the 182 lux from both sides. And we get 2292. Can't be which 2293. And it'd be over 100 centimeters squared. Because the whole 10 centimeters gets squared, so the centimeter also gets squared. Now let's make sure I did my calculation right now. Well, 18 short of 200, and 200, we subtract 200 from both sides, we get 2275. Add 18 to that, we get 2293. Then we multiply both sides by the 100 centimeters squared. And I didn't do that explicitly because we don't have any distributive law or anything to get in the way and cause an error. So it's pretty clear that we multiply that by 100 centimeters squared. So that's I'm a little uncomfortable with that because I think we got just a slightly different number. So let's make sure that you're right and I'm wrong. So what we've done so far is we found K. Now, why do we find K? Well, there's a question in, well, this is what should be L at 20 centimeters. Now, I'm going to let you see if you can answer that. Okay. So I think we got a really good solution. Okay. So what should be L at 20 centimeters? Well, we're using K to rewrite the formula. This situation. L is going to equal 229,300 plus centimeters squared over x squared plus L ambient. Okay, so this now applies to this light source in this ambient context. Okay, and of course we know what the ambient is. It's 182 lux. So all we need to know is X, and we can find the elimination. Luminous intensity. Or if we happen to know L, we could solve for X. Now there's this equation relates X and L. We know one, we can find the L. And in this case, you're given another value of X. You get this? And we see that the units are going to work out. We have centimeters squared here, centimeters squared here, so centimeters squared divide out, and we end up with lux here. We're going to add that to the lux here. Okay, so when we divide this, we get 255 and 225 and 75. Working memory, which isn't all there. So I'll just say about 255. It's not 1,000. It'll be 25. Actually, I've got 2550. and it can't be, gotta be about 1/4 of what you get when you subtract that. Okay, now I'm better. Okay. So 400 into 229 thousand. 400 into 220,000 is 550. Okay. And then it's 552. And then 400 to 1,300 is 325. Big question mark on that. We get this. That's approximately 734 bucks, and all those decimals don't really matter because our instruments would never be accurate enough to justify all those significant figures. Okay, so whether I got that right or not, that's about the right answer. Okay, and that's about what you got. So I wanted to predict how far away we have to be to have a total illumination of 300 lux. And I just let L equal 300 and solve this equation for us, right? Okay. Now, again, I've carried the units through here because I think everybody here is capable of understanding how the units work. Okay, at this stage. A lot of times you'll see the units neglected. And I don't like to do that. I like to be sure the units are all correct, because if the units don't come out right, that means I didn't solve it. And it's a good check. Since the units all came out and the number makes sense, then we're kind of okay. Now, does this number make sense? 20 centimeters is twice as far as 10 centimeters. If I square 20 centimeters, I'm going to get 4 times as much. Okay. So remember that this was a value of K for 10 centimeters, and we had like 2,400 lux. We're going to expect something around 1/4 of that. Although this 182 lux puts a little bit of a wrench into that. So we did get something in the order of 1/4 of this is going to be wrong. So one of my calculations in my head wasn't coming out anywhere near a 4. And I realized that 4 goes into 25 times. Okay. Anyhow, there we have it. Okay. And the whole point is check everything, especially it's a really important situation. If you're in biology studying an ecosystem and you want to come up with something to do with that ecosystem to restore the balance, you want to restore the balance, not throw a monkey wrench into it and destroy it completely. Okay, so you really double check your figures, especially if it's a really important ecosystem. Of course, they're all important because everything's unlocked. Okay. Okay, there's a question about the radical equation. We have square roots on both sides and then some number. So I'll just use 1. It's an easy number. Use 1 in front of X there, but use a different number in front of X. And you'll see why we want to do that. So we square both sides. Okay, well, this side's going to easily give us 4x minus 3. On this side, and I'll fill into more detail than you probably need. But I'm gonna write this as product of two binomials. And then I'm going to get they're starting out the distributive law, just to be sure, you have to be careful, because this looks a little weirder than it usually does. I don't think there's going to give anybody here any problem, but let's make sure. And then I multiply this out. Again, I'm going into more detail than we usually need. But of course, we say we get the square root of x plus 5 plus square root of x plus 5, which is 2 times the square root of x plus 5. And then the product of these square roots is just x plus 5. And that gives us 4x minus 3. There's a plus. Okay. Now what we're going to have to do is end up with the square root of x plus 5 term by itself. And put everything else over the other side. So solving or rearranging the equation, we're going to subtract x from both sides, leaving us 3x. And we're going to subtract 6 from both sides, which will give us a minus 9. Try to write that through a little more clearly. Okay. And at this stage, we square both sides. And without writing out all the details now, we're going to get 4 times x plus 5 equals 9x squared minus 54x plus 81. Then I'll just say, etc. Etc. being, we recognize this as a quadratic equation and solve it accordingly. Now, the equation you have in your homework might have been contrived so that the quadratic equation, that, you know, maybe you end up with a quadratic factors and you don't have to use a quadratic formula. But in general, if you just make up a problem like this, it's very unlikely to factor. So I think the chances are immense if this isn't going to factor. But you've always got the quadratic formula. And the other thing is, there might be no solution because this number is kind of big here. It's a little smaller when you take care of this. And this gets a little bigger. So your b squared is going to be on the order of a couple thousand. 4ac is going to be on the order of over a couple thousand. I suspect that what's going to happen here is this is going to have a solution. Of course, that 81 is going to decrease to 61. So I just changed my mind. I think it probably will have a solution. But we're never going to find out because I'm not going to take any more time with that problem. But you understand what I'm saying is that, okay, first you try to factor 9 there and all those other numbers, it's probably hopeless. Then you resort to the quadratic formula and see if your discriminant is non-negative. If your discriminant's negative, you got no solution. Otherwise, you go through the arithmetic. Okay, there's a question. Somebody said, well, I did another problem where both of the square roots were on one side. Okay, well, both of the square roots are on one side, you can still square both sides. Okay, I'll just jot that down real quickly. If you have this same equation, but all the square roots were on one side, you could still square both sides. Then you're going to get x plus 5 minus 2 square root of x plus 5 square root of 4x minus 3 plus 4x minus 3 equals 1. And then you can just put these radicals on one side. You're going to get minus 2 square root of x plus 5 square root of 4x minus 3 equals, we're going to have 5x here. So it's going to be negative 5x. And you're going to have plus 2. You're subtract 1, you're going to have minus 1 on this side. Okay. And now the radicals are on this side, so we just square this, and we get 4 times x plus 5 times 4x minus 3 equals 25x plus 25x squared plus 10x plus 1. Now we multiply this out and we get 16x squared. We're going to have 20x and minus 3 is 17x. It's going to be minus 68x. And then minus 12 equals 25x squared plus 10x plus 1. If we subtract the 16 from both sides, just compare it with this, look at that, we got 9x squared, just like we did. Okay. And let's say we have minus 68x and plus 10x. Well, that's plus 78x, which I don't particularly like. There might be something wrong there. Plus 23. Now, I think I probably have an error here. So this should match what you get when you put all this on one side. So what I've done is I've just added all this stuff onto this side. How do I get 25 out of 12 and 1? It's 13. Negative 68, we get 23. 20 and minus 3 is plus 68. So this becomes minus 58x. And I'm not sure how I got 12 here. That was ridiculous. I've got 15 here, negative 15, it's minus 60. Okay, and now I've got 61 here, and this matches this because I'll be subtracting 4x to get negative 58x, which would match. And I'd be adding 20, well, subtracting 20 to 81 to get 61. Okay, so the whole point is, other than the fact that I was working past and did a couple of bonehead things, this ends up exactly the same as this. And it should, because it was exactly the same equation. And now we can check our discriminant, and it's easily going to be. Yeah, I did a bonehead thing there when I thought it was in the order of 2,000. That's over 3,000. 4 times this is a little over 2,000. Should be subtracting 2,000 from like 3,400 or something like that. And you'd have like a 1,400 or something like that. 1,300, 1,200 under the radical. Okay, so it would work out. Try to stop this recording.